Cisco Certified Network Associate Day 21. Welcome back everybody, I'm Imran Rafai, your trainer for this entire series. Today we are going to talk about RIP routing, and we will look at all the different aspects of RIP routing, how to configure that, what are the limitations, what are the timers that we have, right? So we will look at everything about RIP in this video. Like I said, RIP is not part of the Cisco 200-120 exam. That's the latest syllabus in Cisco. Does not include RIP, but RIP is a very fundamental routing protocols, which is going to teach us a lot of things about routing. So that's why I'm dedicating one video for RIP. Right, so before we go any further, just like always, please pause the video, like this video, and also don't forget to subscribe to our wonderful channel. Your support is what gives us motivation to create these beautiful videos. And of course, go find our Facebook page. Right, the link is on the bottom left here. Find that page, give us a beautiful review, and of course like that page, right? So thank you so much, and without wasting much time, let's get into today's class. What are we going to look at today? Today we're going to look at three things. We will understand and configure RIP on the routers. We will talk about RIP timers, and then we'll also look at the limitations of RIP. RIP as a protocol was developed in 1969, so it's a very old protocol. The beauty of RIP is it's very simple, and a lot of devices support RIP, whether it is Cisco or non-Cisco. A lot of device supports RIP because this is open source, right? It's not a proprietary protocol like let's say for instance EIGRP, right? So this is open, anybody can use this, and a lot of device manufacturers in fact uses RIP even to this day. But keep in mind, RIP is a very old protocol. So there are two versions of RIP. RIP came with version 1, right? That was a classful version of RIP. That means it did not support variable length subnet masking. So you could only give one subnet, like we will look at it a little later. It also did not support authentication. So basically how RIP works is you have routers. Right, so there is a router here, there is a router here, and these two routers, how routing protocols, as a general rule, how routing protocols work is this router tells the neighbor what it knows, right? So let's say if this is connected to the 10 dot network, and this is the 20 dot network, and this guy is connected to the 30 dot network. If RIP is enabled on both these devices, this device, let's call it router 1, right? And this is router 2. My writings are really bad. My tablet is not working, so I'm just going to get a new tablet. So please bear with me. So let's say router 1 tells router 2 that it knows 10 dot network and 20 dot network, and router 2 tells router 1 that it knows 30 dot network and 20 dot network. So what does know? What I mean when I say knows is this router 1 is connected to router network 10 and network 20, and in the routing protocol I tell it to add those two networks to the routing protocol, right? We will see how it is done. So basically it tells about these two networks to its neighbor, and the neighbor tells to each other, right? So basically RIP protocol is a gossip protocol basically. So it basically believes everything its neighbors say, right? So anybody says anything, it just tells, and it keeps talking. So basically routers love listening to updates, and also it loves telling those updates to its neighbors, right? That's how RIP works basically. It works by gossip. So RIP 1 did not support authentication. That means anybody, so I could get a new router, plug it to the network, and I could start advertising. So basically if this was your office network, your production network, and if I wanted to bring it down, I could just get one rogue router, plug it in, and that will start believing the route updates that is given by my rogue router, There is no mechanism to prevent that. That was in version 1. There was no authentication. But today, if you want to use routing protocol RIP, that is RIP routing protocol, you could set up an authentication. So only if the authentication matches, these will start accepting the updates given by each other, right? Another thing is RIP1 uses broadcast. So whenever there was update, that update was sent on a broadcast ID. That means everybody in that network received that update. So even if there is a computer here, right, and you know computers are not going to take part in the routing updates. Routing updates are for the routers, right? This router would send that everywhere on the broadcast ID, right? So that means everybody was listening to those broadcasts, even those devices that did not have to listen to it. In version 2, that was taken care of, and there was a multicast ID, and the multicast IP is where all the updates are sent. So only devices that is tuned to listen to that multicast IPs, those are the ones that was getting those updates, right? And it also adds authentication, like I said. So you could actually set up an authentication, and only if those authentication passwords match, they will receive or accept updates from the neighbor. Also, it supported classless version. That means you could have an IP address 10.1.1.1 and it is a /24, right? And it can start giving updates, and when it sends that update, it also includes the subnet value, right? So it tells what is the CIDR value, right? So that is what happened in version 2. Version 2, the updates are sent with the CIDR value so that the receiving device knows what is the CIDR value this particular network update or route was with. But whereas in version 1, when this device sends the route information for 10.1.1.0, it just sends that 10.1.1.0 like 10.0.0.0, like a class full version. So it's sent with that full class information without absolutely no information with the CIDR value. So the receiving device had no information to know that this was the subnet of the class A IP address, right? So this is what RIP routing protocol is in very, very basic terms. Now, how do you configure RIP? Now, this is how all the routing protocols are configured. You go to the global config mode, put the word router, right? And then you could put what routing protocol we're going to use. So you can put OSPF, EIGRP, or RIP. And in this case, because this video is about RIP, we're going to put RIP, router RIP. Then if you see here, the prompt changes to router. That means now you've gone into the router subcommand, right? Which is RIP in this case. So now we are in RIP router configuration. In RIP router configuration, we go and we say version 2, right? So just type the word version 2, which means we're telling the router that we're going to use the version 2 of RIP, right? And that is the version that is the latest. So we will not even be looking at version 1. We only be looking at version 2. And the next information that we need to give is we need to tell which network to advertise, right? So this network command is a very tricky command because it does two functions, right? The first function is it tells what network to advertise, right? And the second thing, it is telling which interface to advertise those out of. So hang on, you will see what I mean when you look at the configuration. Right, so today we're going to look at this diagram. So this is our network today. So we have 4 routers, and I have a computer with the IP address 192.168.1.10. Right, you look at this, that I have subnetted this, so it's 192.168.1.0 that's subnetted into 4 networks. So you have the /26. In fact, I'm only using the 3 subnets. So when I do /26, you know it is broken into 4 subnets, but I'm going to use only 3 here. So I'm using the 1.0, 1.64, and 1.128. There is another block, which is 192.168.1.192.0/26, right? That block I have not used it because I did not have, I mean, there was no requirement, so I only used 3. And there is a reason why I'm using 3 here, because I want to show you something. So 192.168.1.0, 1.64, 1.128 blocks I'm using. So IP address is 192.168.1.10 and 1.1 here. This is 192.168.1.65 and 66, right? So if you look at it, I spoke about a convention last time. I can't follow that convention here. I can't give this IP address .1 because .1 is not part of this IP address. So what I've done is the first 2 IP address of those networks I've given. So you can see 65 is here, 66 is here, 129 is here, 130 is here. So that's the first valid IP. This is the second valid IP. And in this case, I have used a different network. So you had this 192.168.1.0s here, and then I am now using a different 10.1.1.0/16, right? .1.2. So basically, this is a network that I have configured or I've designed. Now I need to configure this IP address. So basically, I'm going to put these IP address on the devices, right? So let's do that first. Go into the router. So I'll say no. Right, and I say enter, configure terminal. Let's do the hostname router 1, interface F0/0, IP address 192.168.1.1, 255.255.255. Because it is /26, it is 192. I'd say no shut. This has come up. Now I'm going to say interface F0/1. That's the next interface. I'm going to quickly run through because this is just IP address configuration. So IP address, and what is the IP address we're going to do here? 192.168.1.65.255.255.255, 192, no shut. Right. I'm going to come here. I'm going to go into CLI, and I will say no. Okay, enter, configure terminal, host name R2, that's the router 2 there, interface F0/0, IP address 192.168.1.66, 255.255.192, no shut, interface F0/1, IP address 192.168.1.129.255.255.255.192, no shut, right? So I'm done with this interface now. So I'm going to go do here again. What's IP address? Okay, so I'll say no, enter, configure terminal, host name R3, interface F0/0, IP address 192.168.130.255.255.255.192, no shut. Interface F0/1, and now the IP address changes. IP address 10.1.1.255.255.0.0, because this is /60, no shut. And finally, I'm going to put this IP address here. Say no, and host name R4, that's router 4, IP, interface F0/0, IP address 10.1.1.2.255.255.0.0, no shut. Brilliant. So at the moment, we have configured all these devices, and I've already given an IP address here, so you can go look at that. 192.168.1.10, 255.255.255.192, 192.168.1.1. This is how you give an IP address. This is how you look at subnetting. So when you do subnetting, how you change the subnet mask value to get the subnet that we want. Very simple. There's nothing new about this. Absolutely, absolutely easy. Now let's enable routing. So I'm going to go here. I'm going to go to global config mode, and I type router. Let's do a question mark. So it says, now this is what is supported in packet traces. So BGP, EIGRP, OSPF, RIP, right? So we said in this video we're going to look at RIP, so I say RIP, right? Now let's do a question mark. Alright, so under this we have a lot of functions like auto summary, default information, network, redistribute, timers, like a lot of information which we will not be using until we reach, let's say, ICND2. Some of them we will be using, but the most important thing is the version. So we start version, like I said, we only use version 2, so we go to version 2. The next that we're going to use is the keyword network, right? So when you say network, let me do this. Let me not start with router 1. I will come back to router 1. Let's start with router 3. So I go here, exit router RIP. So we have got into RIP sub configuration. I say version 2. Now I say network. And let's start with this side, right? So this interface is 10.1.1.1, right? So how RIP works, even though we're doing version 2, when you're doing the network command, right, you can do a question mark here. It says give the network number. So even if we are doing /16, right, that is because subnetting is done on this network, because 10 is a class A, but because subnetting is done, it's /16, right, instead of /8. But RIP, being such an old protocol, still accepts it in its original class. So when you give this, you have to give it in the class full version of that IP address. So the network command will take this, accept it. The network command will accept it in 10.0.0.0 form. Now, even if you were to, let's say, subtype, let's say 10.1.1.1, right? Even if you type this and let's say do show run, you will see that where's that router RIP? Yeah, you'll see that it took that command, it had automatically converted it for you into the class full form, right? So if at all routing or a RIP comes in your CCNA exam, you have to type it in this form, 10.0.0.0. If you type it 10.1.1.1 or 10.1.0.0, they will score you down, right? So iOS does its work of converting it and making it in the correct form, but it's up to you to write, not wait for it to correct it and you do the correct thing. So remember, in RIP, you're always giving the class full version of the network. Now, what happened when you give this command? When you give this command network 10.0.0.0, it injected this network 10 into the routing protocol. And it also told that routing updates need to be sent out on this interface. Right, so now updates are going from router 3 to router 4, right? So let's go to router 4 and set up routing protocol. So I go router RIP and I say network 10.0.0.0, let's say first version 2, network 10.0.0.0. Now what happened is I told this router, I enabled router RIP on it, and I told start advertising this 10.network onto the routing protocol. Now these two routers would have exchanged information, but it wouldn't have done anything. So when I say show IP route, you can see that it says it is connected to the 10.1.0.0 network directly. Router 3 is advertising which network? It's advertising the same network. So this device, router 4, says he receives those updates and says, okay mate, thank you so much, you're giving me those updates, but I think I already know about it because I'm connected to that interface, right? So let's do this. Let's go here and introduce the other network. So when you say network 192.168.1.0, I'm doing the class full, class C, so I'm going to give the 1.0 network. And when I type this, it has now started advertising 192.168.128 into this this side. So it's added into the routing protocol, and it started advertising that in this onto router 4, and also the 10 dot it has started advertising into router 3. Well, not exactly. What happens is basically, like I said, RIP works on gossip, right? So basically it tells the entire routing table. So let's look at this routing table. So show IP route. Now this is the routing table. It has, again, like, it has not learned anything new because we just enabled a RIP on both interfaces basically, right? And it has not learned anything. So basically the routing updates that this router 3 sends out will contain this entire thing, everything that it knows in its routing table. At the moment it only knows 2, so it is going to send both that to both the device. So it's going to send to router 4 and to router 3, or rather router 2. Now let's enable routing protocol in this as well. So I'm going to go here, configure terminal, router RIP version 2 network. Right, now it gets interesting. Now this router, when I say 192.168.1.0, I'm saying 1.0, but this is also 1.0, this is also 1.0, right? That's interesting. So when I just hit once, this technically enabled routing for both interface, because 1.0 is for both, right? So beautifully, just by one command, this router enabled routing in all its interfaces. And similarly here, I'm going to go here and we did version 2, so I'm going to say 192.168.1.0. I enabled routing on both the interfaces, right? So now let's look at the routing table here. Show IP route, right? Now you see that it has learned 192.168.1.28. So this router knows 1.0 and 1.64. It didn't know anything about 1.128, but it learned 1.128 using RIP. Similarly, it also learned about the 10 network that is here, right? It learned about the 10 dot network through through RIP protocol, again R, right? One thing I want you to look at is this information. This is the administrative distance, right? So administrative distance is the trustworthiness of a routing protocol. So when you look at a routing table, you will have an administrative distance, right? So RIP has an admin distance of 120, right? In routing, in admin distance, the lower the better, right? The static that we did, static route has a distance of 1. So in the routing table, if there was another route here, let's say static, and it says 10.0.0.0 using static route, that means it will be 1, and it has to go through a different route, the routing table, this device will always send the traffic out on that whatever the route has a lesser admin value. So in this case, if there was a static route for the same network, the static route would be taken into account, right? So that's what admin distance is. The second value here is the metric, right? In RIP, the metric is hop count. So it's telling the 10.0.0/8 network can be reached in 2 hops, right? So it is from here, it's telling 1 hop, 2 hop, and you are in the 10 dot network, right? So it's telling in 2 hops you can reach 192.168. You can reach the 10 dot network via 192.168.1.66, which is this, via 1.166 you can reach, which is on the fast Ethernet 0/1 interface, right? It also says it can reach 192.168.1.28 using, it has an admin distance of 120. In 1 hop you can reach that via this. So that means you come here and you are in this network, right? So that's what it says. Now, so this is routing. So basically now this device, if you want to ping, so if you say ping 192, or rather 10.1.1.2, which is this interface, right? it is replying back. It lost the first one for it lost the first one because of ARP, so it was just doing the ARP and it lost the first one. But basically, it started getting reply from everything of the next 3 packets, and it's working. So basically, end-to-end communication is happening now using the routing protocol RIP. That is the basic requirement. So just to summarize, to enable router RIP, you just say router RIP and then say version 2 for the version 2 of RIP, and then you give network command and give the network IP address or the network ID in the class full form. Right. So now when you come here and you say show IP route on route 4, you will see 10 dot is directly connected, and 192.168.1.0/24 is directly, it is available through 10.1.1, and it is an update it received through routing protocol RIP, right? There is a problem here. If you see, it says 192.168.1.0/24. Right, we'll come back to it. It is an auto summarization problem. I will tell you what that is. Right, so next let's look at the timers. So RIP has 4 basic timers. The first timer is the update timer. Update timer is a timer that that's the interval it takes for updates to go out. So every 30 seconds, RIP sends out update to all the interface participating in RIP routing. That means it takes this entire routing table and it sends out in all the interface that is working with RIP, right? So let's say this is router 1 and this is router 2, right? And this has a network here and this has a network here. This is, let's say, N1, network 1. This is N2, that's network 2, and this is N3, that's network 3, and this is router 1 and this is router 2. Now router 1 tells router 2 that I know network 1 and network 2, so it sends the update. And router 2 tells router 1 that I know network 3 and network 2. Fine. So every 30 seconds, these both will start exchanging its routing tables. Now let's say for some reason this link breaks. So network 1 is now router 1 does not know anything about network 1. So the next time when router 1 tells router 2, it only updates about network 2, right? So router 2 says, okay, this network 1, now I'm going to put it in invalid timer because I did not get any updates about network 2, right? So it goes to invalid timer. So an invalid timer starts. So for 180 seconds, the invalid timer starts. In that period, if it gets an update about network 1 from either router 1 or router 3, anybody, another router from somewhere else, if it gets an update for that network 1, it resets that invalid timer and it starts counting the update timer again, right? You with me? So if it doesn't get any update for N1 in 180 seconds, it's going to put that network into a hold down state and a hold down timer starts running, right? But at the same time, there's another timer. From the time that invalid time clicks on, that means from the time a new update hasn't come after the 30-second interval time update is gone, a flush timer starts. When the flush timer reaches 240 seconds, automatically that network 1 is removed from network 2's routing table, right? So this is what the timers are. So we have the update timer every 30 seconds, then we have the invalid timer which runs every 180 seconds. That is the timer it is going to wait until a new update comes for that router. If it doesn't come, it's going to put that network into a hold down state, and a hold down timer of 180 seconds starts. But with this invalid timer, another timer called the flash timer, you can see it here, invalid and flash starts together. So when the flash timer, it's invalid and flush starts together, and flash it seems, anyway. So invalid and flush timer starts together, and in 240 seconds, when flush timer reaches 240 seconds, that network, whichever network that flush timer was in, it deletes that network from the routing table and the updates are sent back. That's what the timer is. Now let's look at the limitations of RIP. RIP has a lot of limitations. One of the main limitation is what we spoke about earlier, auto summarization. So if I go back to a network, and here it tells RIP has told, that means this device, router 3, has told router 4 that the entire 192.168.1.0/24, when you say /24, if you watched our earlier video, 192.168.1.0/24, that means the entire network of 1.0, that is 256 IP addresses, including the broadcast and the network ID, is available, right? So basically, you're telling this routing, if there is a traffic that is coming to 192.168.1.225, 226, or 227, whatever, this device is immediately going to forward that traffic to 10.1.1.1, right? So 10.1.1, let's look at it here. Show IP route. If a traffic from 192.168.1.255, or sorry, 225, right, some IP address that is not in this, right? So it only knows about 192.161.0, 1.64, 1.128, all /26, right? It doesn't know anything about 192.161.192/26. That means every IP address from 192 onwards, 192 till 255, those IP addresses he doesn't know. But for some reason, router 4 is thinking that it knows everything, right? So, and it is forwarding traffic. Now this is absolutely wrong. This is a classic case where traffic will start, your router will start dropping traffic because they're lying to each other, right? So this device can't, router 3 can't tell router 4 that it knows everything. That's happening because of a problem called auto summarization. Auto summarization, especially it happens when traffic, right? So this is when traffic is crossing over to a different large network, right? So basically from 192 1.0, that whole class C, it's going into something else. It's going to a 10. So at that border, this router says, you know what, I'm going to I'm crossing over to a different network, right? A different large network, right? This was a 192.168.1 dot thing, so he was thinking it's all similar. Now I'm going to something else. I'm going to 10 dot something, so I'm going to auto summarize it. So it's going to automatically summarize it into 192.168.1.0. Remember earlier we spoke about summarization, right? Supernetting summarization in one of our videos earlier. So this is what's happening. The reason they do that is it becomes easy. Like in this case, this one command, one routing table entry, one entry is better than having 4 entries, or rather in this case 3 entries, right? So in this case it's small, so it's okay. But then you could have a situation where a network is broken down or subnetted into, let's say, hundreds of small subnets, and if we don't do summarization, this routing table will have a lot of information or lot of entries in the routing table, and to prevent that, automatic summarization is taking place. But automatic summarization is in a way creating more trouble to us because it is telling information that is not true, right? So we need to go here and tell it not to auto summarize. So you can go into the router routing configuration, so router RIP, and I say no auto summary, right? So I'm going to wait for that update to go to this device, and I say show IP route, right? So now this is what it learned earlier, right? So 192.161.0/24, it was advertising earlier. Now this will go off in a while. We'll look at all the timers. So when we do this, we'll see that every 30 seconds this will reset. This is the update timer. right? So it became 30 and it reset. But this in last 30 seconds, it did not get an update. So that's why its timer is still going above. It's gone to 1 minute now, right? 1 minute 10, 1 minute 11 seconds. If you see here, sorry, it's 1 minute 19 seconds, 1 minute 22 seconds, 24 seconds, right? So it will, what is our flush down timer? If you remember, it is 240 seconds after the update. So 30 seconds plus 240 seconds, 270 seconds, it should remove that network from the routing table. So 192.168.0/26, this is right. 1.64/26, 1.128/26. So now when a traffic comes for 1.192.168.1.225, this device is going to drop it because it says I don't know where 1.225 is. But in the earlier case, when we did not do auto summarization, for some reason, because of auto summarization happening at router 3, it was sending the traffic to 10.1.1, which is absolutely wrong. It should have dropped the packet here, not sent it to router 3, and router 3 dropping the packet. So as a network administrator, you have to design a network where less and less, like in this case, there was absolutely no need for this traffic to go till router 3, right? You can avoid it traveling that much. So as much as possible, reduce the bandwidth that is going to go unnecessarily onto the network, right? So that's what you do with summarization. Another thing is about loops, right? As we saw, the convergence is the routing table getting updated with the correct value. So when a router went down, so in this case, even though we put it off, it's as good as the router going down. It's not getting an update for that. So it did not hear about this network 192.168.1.0/24. It did not receive an update for that particular network for a very long time, and it's still not gone out of the routing table. So it's this convergence is the term that is used technically for routing table to be updated to the correct information, right? When a network goes down, immediately all the devices routing table is updated. When it comes up, automatically it's updated, right? Convergence is a state when all those updates are done and everything calculation is done and the routing table is updated. RIP has a very, very bad convergence figure. So it's very, very, very slow routing protocol. So because of this slowness, what happens is you have a situation where a routing loop happens, or basically a problem which is known as counting to infinity problem. That is, let's say this is 1, this is 2, right? And this is network 1, like we discussed earlier. This is network 2 and this is network 3. Okay, now for some reason this goes down. Now already network router 2 knows that network 1 can be reachable in one hop through router 1, but now network 1 has gone down, and router 1 has already put that in a hold down state. It is an invalid timer state, right? It's an invalid timer state before it goes to hold down timer, and it started that timer process that we discussed earlier. Now when that happens, let's say router 2 just went through its update timer and it has to now update. So it updates. So in its routing table, it has a figure which says network 1 is reachable in one hop. So what it does, because what RIP routing protocol does is basically gossip, right? So it sends that update to this device before router 1 could tell router 2, hold on, I'm not giving you an update, right? So before that update happened from here, before that 30 seconds timer expired on router 1, and before router 1 could send that update to router 2 without network 1, router 2 already, let's say, assume, sends that update back to router 1. So now router 1 looks at it, says, okay, I had router 1 directly connected to me earlier, but for some reason that has gone off. But router 2 is telling me that network 1 is available through it with hop count of 1. So what I'm going to do is I'm going to add one hop. So now I'm going to update my routing table that network 1 is available through router 2 with a hop count of 2, right? Now that update goes back to router 2. Now router 2 looks at it and says, okay, earlier I got an update from router 1 saying that network 1 is available with a hop count of 1. And now it is telling me that network 1 is available with a hop count of 3. Maybe something changed, so I'm going to update my routing table. So router 2 is going to go update its routing table because it received an update saying with 3 hops. Router 2 is going to say, okay, I'm going to add one more. So now network 1 is available at 4 hops. You see the problem? They're going to tell each other by adding one hop count, right? So finally it reaches a stage where it goes to a big number, right? So this is basically a problem because of the slow convergence of RIP. Now what happens in RIP, because the maximum hop count RIP supports is 16, any hop count more than 16, immediately those devices realize that, okay, fine, there's some problem, I'm gonna delete those routes. So both of them will start deleting the route when the network hop count goes above 16, right? So that is the looping problem that RIP has. And then there is an inherent problem with distance vector, because distance vector, like we discussed earlier, it looks only with the distance. It doesn't look at the link state. So that's why distance vector is not such a great routing protocol. So the metric used is distance vector, like we discussed earlier. And in 1969, when this distance vector protocol RIP was developed, I think those days computer networks were so slow, I think it made more sense, or rather, the routers also did not have that much processing power. So maybe the designers did not want to complicate the stuff and slow down the whole process. So they chose a very easy and very trivial, very basic metric, which was hop count. But in today's world, that's not ideal. So distance vector has an inherent problem, and that's why we will look at a much advanced routing protocol called OSPF, and that is the industry de facto industry standard today, and a lot of companies use OSPF. So we will be looking at OSPF in a much in-depth form in our future videos. But like I said, we wanted to give you some introduction to RIP, and that is this video. So we will not be coming back to RIP again. This, I think, has a lot of information that you need from a RIP's perspective, right? So what we will be looking at henceforth would only be OSPF and EIGRP, right? So that has all the information that you need for today, and I hope it was very informative. Once again, thank you so much for watching. Please subscribe to us, give us a review on Facebook, like our page on Facebook, like this video, make sure this video gets about 1,000 likes, you don't know, and share these videos. Just click that share button. It's very easy. You're not going to cost you any money, but it's going to give us more viewers, and it is going to make it start motivating our team to put more resources and time and create those videos, right? So thank you so much for all those people who have liked us and subscribed to us, and all those people who are writing into us with a lot of things. We're trying our best to give you a reply to all of you, but we understand that not everybody can be replied to, but very soon we will start replying to your questions as well. So thank you so much, and hope to see you in the next class, next video very soon. Thank you. Bye bye.